Hey everybody, how's it going? Today's video is going to be a little bit different than some of the other types of videos that I have been making up to now. So, I really kind of wanted to start getting into some actual development videos, and so today is actually going to be kicking off a brand new series of videos focusing on game development. And what we're going to do in this series of videos is we are going to make a small, simple game using TypeScript, and it's going to be browser-based. And there's a couple of reasons that I've chosen this language and that platform. And the primary reason for that is it's cross-platform compatible. It'll run on a mobile phone, it'll run on your desktop computer, of course it'll run on Windows, it'll run on Mac or Linux. And TypeScript is a very straightforward language for the most part, and it's very easy to sort of get up and running with. I could do some other languages maybe down the road. Maybe I'll do some C++ or C# tutorials, but for the purposes of this series, I've chosen to go with TypeScript. So what TypeScript is, it is as defined here, it's a superset of JavaScript that compiles to plain JavaScript. So for those of you who don't know, JavaScript is the programming language that makes things happen within the browser on web pages. It can modify elements on the page, it can make things appear and disappear, it can animate things, it can make web requests, it can do all kinds of dynamic things. Chances are any web page that you hit today is using JavaScript in one form or another. So the way that TypeScript works is it actually transpiles down to JavaScript. And what that means is a transpiler is a little bit different from a compiler in that a compiler ultimately compiles down to machine code, which the processor understands, versus a transpiler, which basically takes the language and converts it to another language that's then interpreted. So all browsers have JavaScript interpreters. TypeScript outputs to JavaScript, which can then work in any browser. It can also work with Node.js, if you're familiar with that at all. But that's really outside the scope of this video, so I don't really want to go into that too much. So just to give an idea of the stack that I'm using for this, the technology stack and the toolchain set, I'm using TypeScript with Visual Studio. So obviously to follow along with these tutorials, you'll need to be working on a Windows machine. I may at some point make a supplemental video on how to do this in a Linux environment, but for the purposes of this tutorial right now, I'm just sticking with Windows. So there's a couple things you're going to need. The first of which is going to be, of course, Visual Studio. This does work with 2015 rather, but I recommend grabbing 2017 because it's the most up-to-date version of Visual Studio out there, and it has the better debugging capability and newer upgraded toolchain. So what you'll want to do is you'll want to go ahead and grab this community edition here if you don't already have it. Download and install that. When you get to the installer, it's going to look something a little bit like this, and I actually have several things available here because I've got a few different tools and whatnot installed. But the one you're going to be concerned with is this Visual Studio Community 2017, because that's the completely free edition of Visual Studio. So a default install is not quite enough for what we need. We need a couple of extra things. So in my case, I've already actually got this installed. When you go to install it, you'll need to follow some steps that are a little bit different than this, but some of the screens and whatnot will look familiar because they're the same. In my case, I'm going to hit modify. And when you get the installer, you actually wind up getting a screen that looks very similar to this. And what we're actually interested in is a couple of things here. So first off, we want ASP.NET and web development. This is going to provide some of the debugging and tool chains that you're going to need in order to actually create a web application. And I believe that's it on this screen. Yeah. And individual components. You'll want to actually scroll most of the way down, and you'll need the TypeScript SDK. Now, I realize that it says here on the TypeScript website that TypeScript 3.0 is now available. I'm not sure when that was released. It must have been very, very recent because I've not actually used it yet. And the latest one that's actually integrated with the Visual Studio is 2.8 at the time of recording for this video. So that's what we're going to go ahead and use for the purposes of this tutorial. You'll note that I've got all these other versions installed here. You don't have to install them, but I've been installing the new ones as they come out, so I have all these new ones here, or all these previous ones here, as well as 2.8 here. So really the one you're going to need is going to be the 2.8 SDK. You'll want to make sure that's installed. As I said before, I already have that installed, so I'm actually going to cancel this. Okay, so once you have that, one thing that I would recommend doing outside the context of this video is actually take a look at this website, which is typescriptlang.org. This is a wonderful resource on using TypeScript and going into some of the nuances of the language. If you're really looking to learn more about the language, I highly recommend visiting this site and having a look through their documentation. But for now, I'm just going to provide a very brief overview of how all this stuff works. So with that being said, let's go ahead and jump into it. So before we move on, I just want to mention that everything that I do is actually going to be checked into my GitHub. So each one of these videos will have a commit that is made with the content of that video being checked into this repository, and it's the TS Engine Tutorial, TypeScript Engine Tutorial series. So it's actually going to be, everything's going to be checked into this repository. As you can see here, there's nothing here. All I've got is a git ignore. I'm not going to go into the nuances of actually using git in this video. It's something that you can very easily read up on another time. You may see me check things in from time to time or whatnot, but I'm not really going to cover that in this series. But I just wanted to mention that all the code will be downloadable from this repository. So I'm going to go ahead and launch Visual Studio. Alright, and I'm going to create a new project. Okay, and what I want to do is under the Visual C#, I want to choose the web selection here. And we're not actually going to be doing anything in C#, but that's where the template is that we need to actually create our application. So what we want to do is we want to select ASP.NET Web Application .NET Framework. We don't want the core web application one. We want the .NET Framework one. So it's on my screen, it's the second option here. And I've actually cloned this repository onto my machine. So I'm actually going to copy this directory here, and I'm going to call this TS Engine. Okay. The version of .NET doesn't really matter. I'm just going to leave that at 4.6.1. And I do not want to create a directory for the solution, and I do not want to create a new Git repository because that's already actually been done in my case. So with that, I'll go ahead and click OK. And next we get this this wizard that comes up asking us what we actually want to include. We want to roll with an empty project. We don't want any of the defaults in here, because what I want to do is explain each individual piece of this so that there's an understanding of how all this stuff comes together. So with empty selected, I'll go ahead and click OK. And that'll take a minute to create. Okay, and there we are. So we're given this overview page. I'm going to go ahead and close that. So if we look at the Solution Explorer, we're given our solution and our project over here. And we're given two files in here. There's a packages.config, which is for NuGet packages, and we're given a web.config, which is used to actually run this web application in a browser. So we're actually going to leave those two things alone. The defaults are fine. We don't need to do anything there. What we do need to do is we need, first off, a web page to hit when we run our application. So everything that we're doing is going to be within one web page, but the first thing we need to do, of course, is create that. So I'm going to right-click the TS Engine project, and I'm going to add new item. And what I want is an HTML page right here. And we're just going to call this index. Index is the default name of any web page in a website. There's also some other defaults out there, but index.html is the most common one, so we're going to stick with that. Okay, so Visual Studio is kind enough to scaffold out this basic web page for us that gives us some of the basic structure that we're going to need. So I'm going to go through this real quickly because this isn't really an HTML tutorial, but here we have the doc type declaration. This tells the browser what version of HTML we're using. In this case, we're using HTML5, which is just denoted by saying doc type HTML. This is actually required in a lot of cases to actually get the rendering for the canvas rendering to work properly on several browsers, and we're going to run into that later. I'm not going to go into that now, but we do actually need this. You'll see some web pages exclude it and they'll just have this, but that's actually not proper HTML. Valid HTML requires a doc type. So we'll have this wrapping HTML element, and then inside of that we'll have the header element, which includes a meta tag just giving the browser some encoding information. We can leave that as is. And for the title, we're just going to call this TypeScript tutorial. Excuse me. And in the body, I'm just going to put some text. And this is really just to demonstrate that the page that we're creating is actually what comes up in the browser when we run this. So before I go any further, I'm actually going to press F5 to run this. And that's going to run through a compilation, which there's no actual code to compile here, and then I'll just run the page. So as you can see here, we have a web page that says some text, and our TypeScript tutorial title is reflected up here. The other thing you'll notice is that it's running on localhost, which means it's just running on this local computer, and it chooses a port number seemingly at random, and then we're on our index.html page. So great, this looks exactly like what we expect. So let's go ahead and close that. Okay, so the next thing that we want to do is we actually want to write some TypeScript. So the first thing we're going to do is, again, right-click our TS engine, and we're going to say Add TypeScript file. Now you can also say Add New Item and find TypeScript in there, but for me, it's a lot quicker just to select it from this list. So I'm just going to add a TypeScript file, and I'm going to call this app.ts. And this is a fairly standard way of naming your main application TypeScript file. You don't have to name it this. It's just what I'm choosing to go with in this case. This will contain the main code that's actually going to be executed when the page is loaded. So go ahead and click OK on that. And now we have our TypeScript file. So there's a couple of things that we're going to have to do here, and some of this involves a little bit of JavaScript. The JavaScript that we're going to have to write, remember TypeScript also outputs to JavaScript, so you can actually put straight JavaScript in a TypeScript file, and that's actually what we're going to start off with initially until we actually need some of the features of TypeScript. So the first thing I'm actually going to do is I'm going to say window.onload, and I'm going to set that equal to a function, and it's not going to take any parameters. And what we're basically saying here is when the window is loaded, this function will be executed. Okay, so what we're going to say here is document.body. So that's a reference to this body element here. So this whole thing is the document, this is the body. .inner HTML. So there's inner HTML and inner text here. Inner HTML is basically going to allow us to insert HTML directly into the page, or replace the HTML that's in the page with what's defined here in our code. And inner HTML takes a string. So if we hover over that, you'll note that the type of inner HTML is a string. So what we're going to do is we're going to say plus equals, meaning we're going to append the contents of a string to the body. And we're just going to say foo and put a semicolon at the end. Now, JavaScript nor TypeScript require the semicolon at the end. However, it's good practice to put it at the end. Some people may disagree with this, but I remember reading a story a few years back where Twitter had actually written their entire API not using these, and they actually ran into a problem because it became so large that the interpreter actually had problems with it, and they had to go through and add these things to their API all over the place. So that, coupled with the fact that it just looks a little bit cleaner, it sort of falls in line with some of the other languages that are out there. So what this is going to do, this whole line, is it's basically going to just append the text foo onto the page when this is loaded. Now, if we were to run this right now, we're not actually going to get anything. And that's because we're not actually referencing this code from the HTML page. So in order to do that, there's actually a couple setup items that we need to do first. So the first one of those things is to right-click the TS Engine project, and we want to say Properties. And all the way at the bottom, we have a TypeScript Build tab. And when we select that, we're given all sorts of options here on specific TypeScript compiler options. So as you can see here, we have TypeScript 2.8 selected. We could use latest available, but I prefer to select a version. That way, if I install a newer version of TypeScript on this machine, I don't have to worry about potential breaking changes having happened. So I like to explicitly select a version. ECMAScript 5 version. This is the version of ECMAScript, or the version of ECMAScript that's going to be output. So there's 3, there's 5, which most devices support 5. 6 is fairly new, and these things, of course, are very, very new. So I'm going to stick with 5 right now because I don't need anything newer than that. Just understand that if you select one of these newer ones, it may not run on some devices, namely mobile devices, because a lot of mobile devices do not yet support anything beyond ECMAScript 5. So I'm going to leave it at that for right now. And the next thing I want to do is down here we have this combined JavaScript output into file. So by default, the TypeScript compiler for every one of these TypeScript files outputs a JavaScript file of the same name. And I prefer to keep my code split up among multiple files. It just is a lot easier to manage, it's a lot cleaner, and you avoid having to scroll the page all the time because you've got tons and tons of code in one file. It's a common thing that a lot of developers prefer to do, especially when your code base grows. So what we're going to do here is actually we're going to enable this option, and we are going to output it to, we'll say, main.js. And it's going to take all the output from all TypeScript files and output it to a single JavaScript file that we can then reference. And that should be all we need to do for right now as far as these options are concerned. So we'll go ahead and save that and close that for right now. And one more thing that we need to do is back in our index.html page, we need to reference that output file. It doesn't exist yet, but when we compile, it will actually show up. So to demonstrate this, actually, let me go ahead and just bring this up to show you what we have here. So we've already compiled once this app.ts, and you'll notice that we have an app.js and an app.js.map. And this js.map contains some information that helps the browser map the JavaScript to the TypeScript. So when you're actually debugging, you can debug the TypeScript, not the JavaScript, which is kind of cool. I'm not going to go into that for right now, though. So if I delete the app.js and the app.js map, because those are generated, and I recompile this, you'll note now we have a main.js and a main.js.map. So if I examine this main.js, this looks remarkably like the JavaScript that we wrote in our TypeScript file. So nothing fancy has happened here yet. We will come back to this and look at this later. But just understand that this is ultimately where all of our JavaScript is going to wind up. So this is the file that the browser is actually going to be referencing and loading. And actually, real quick, let me just show you what this file looks like. Now this file gets kind of crazy with the mappings. The more code you have, the crazier this mapping gets. So you don't need to really understand what's going on in this file, just understand that it's there. I just kind of wanted to bring it up as a reference point. Okay, so now that we have our main.js generated, that is going to be, as you may have guessed, the file that we're going to reference. So in our document header, what we want to do is we want to add a script element, and we want to set its type to text/JavaScript, and we want to set the source equal to main.js. Okay? And what that's going to do is that's going to load up our generated JavaScript file when we launch the page. So if I go ahead and hit F5 to run this, whoop, I've got an error there. Let me see what happened with that. One moment. And I'm back. Sorry about that. I actually had an issue and needed to reboot. Gotta love Windows. So anyway, what I want to do is go ahead and run the application just to show that the body actually does have foo attached to its inner HTML. So let's go ahead and do that by pressing F5. And as you'll see, we have some text, and then foo is appended. So we know that our JavaScript is being executed properly. So this is everything that we need setup-wise in order to actually start making our game in TypeScript. So the next thing that I want to go ahead and do is I want to set up some basic things as far as getting a render loop going, a game loop going, and set up some of the basic things that our engine is going to need. And we're going to start off very basic with all of this and build more on top of it as we sort of continue through this. So, okay, so the first thing that I want to do, at least for right now, is I want to put in a namespace. I like to keep all of my code in namespaces. And a namespace is really just a container for classes or global constants or anything that you want to keep sort of related items together. And it's a nice way to organize your code, and you should really get in the habit of utilizing them because almost every language out there supports them. And they're supported widely for a reason, because it makes things very easy to organize. So in this case, I'm going to go ahead and just create a namespace, and I'm going to call it TSE for short, TypeScript Engine.
And a namespace is just declared with curly braces like that, and that's it. So anything that we want inside of this namespace, we start off by typing namespace and then the namespace itself in the file, and then we can add whatever we want inside of that. Now the next thing I want to do is I want to create a small class. And to do that, we type class, and I'm going to call it engine. And again, we're going to have this open and close curly brace. And the next thing that I want to sort of talk about is I want to export it. And what exporting does is it allows us to reference whatever it is that we're exporting in another file aside from this TypeScript file. So when we go on to create other TypeScript files, we may want to be able to reach out and call the engine, and we won't be able to do that unless we actually use the export keyword. So the export keyword is actually going to allow us to export our engine class for use on other files, and we're not going to see that right away, but we are going to see that soon. So I just kind of wanted to mention that real quickly. And from there, we need to create a constructor. And we create a constructor just by simply typing constructor, and we are not going to be passing in any parameters, so we're just going to use open and close parentheses. I prefer to always use scope. So basically what this scope means is where this constructor is going to be accessible. So TypeScript has 3 levels of scope in terms of functions and variables when it comes to classes. So the first one of these is public, meaning anything outside this engine class can access it. There's also private. Whoops, if I can spell here. So there's private, which means only methods inside this engine class can actually modify this. And in this case, I've marked the constructor as private, which you might not think that you ever do, but there are many times that you actually need to do this. But in this case, that's not what I want to do. And the last one is protected. And what protected does is it allows this class and any classes that inherit from this class to access this particular method. So there may be cases where you don't want to create a new instance of this class outside this class. Maybe you only want to create it in a static method or something like that, where private or protected would make sense. But I'm not going to get into that for now. Let's just go with public. I should also mention that the default scope for things in TypeScript, as it is in JavaScript, is public. So technically speaking, if you're just doing this, where you don't declare a scope at all, that is public. So this is basically the same as saying public constructor. However, in my code, I prefer to be explicit because it makes everything look uniform and nice and clean to always declare scope. So it's a best practice that I've adopted over the years, and I found it to be really helpful in making sure that the code is readable for others when they go to program against it. So it's always something you should get into the habit of doing, no matter what language you're working in, is always declare scope. Okay, so in this case, our constructor is going to be run whenever we create a new engine. So if we were to come back down here to our onload, and we say, we'll say var e. Do I want to use e? Yeah, e is fine for now. Equals new engine. Up. Okay, so this actually brings up another point. So if I just type engine, that's not going to work because the compiler doesn't actually know, like, hey, what is this engine you're talking about? And that's because it is in the TSE namespace. So this window onload function here is located outside the scope of this TSE. So this is a very good example of why namespacing is important and how it can help you organize things. So it doesn't know what engine is, but it does know what a TSE.engine is. So the TSE is the namespace, and then you can say engine. So what this is saying is I want to create a new object inside the namespace TSE of type engine. And so when you type new TSE.engine, it calls this constructor. And this is what creates the instance of this class, sets up any variables or internal data that's needed in order for this class to actually run, and then returns it to a variable which can be stored somewhere. Now, without going into this too much, you'll note that I actually have declared this variable as a var, and there are two types of variables in JavaScript. As of, I believe it's ECMAScript 5, or it might have been 3 that added the let keyword. I forget which one it is at this point. But what I typically do is I use var for global variables and let for local variables, because let makes sure that the variable is scoped to that particular function. And when I say that, I mean within these curly braces, this is the scope of this function. Var, in some cases, can actually allow your scope to be outside of this function, and that can get really confusing. So for clarity, I usually use let. And what this is saying is basically this e variable is only accessible within the body of this function that I've created here. So what this is going to do is create a new engine, and to prove that it's actually doing this, what I'm going to do is I'm going to output to the debug console, and I'm going to say console, which is the browser's console object, dot log. And what this does is it allows us to put in any sort of text to the console of the browser. This is extremely useful for debugging purposes. For now, I'm just going to type something super simple. I'm just going to type hello. And so this is going to print hello to the debug console. And so we will know that when we see hello, that an instance of the engine has been created. So with that, I'm going to go ahead and run this real quick. Okay. And we'll note that nothing new has appeared on the page. However, if we open up the DevTools, in this case in Chrome, I can open this up just by hitting F12. We get our console up, and we'll see that hello has been printed out to the debug console. So this debug console is a very useful way to debug your code, because you can output messages here that don't necessarily appear in the page, and you can output other data here as well. So I just kind of wanted to point this out. You're going to be using this a lot, so get used to having that open while you're developing. And I'm probably going to go into that more in a later video. So the next thing that I want to set up is I want to set up a very basic game loop. And in order to do that, there are a couple of things that need to happen. First off, we need to basically tell the browser that we want a loop to continuously run. And we also need to provide a function that is run every time we loop. And it's not going to be as simple as just declaring a while loop somewhere, because a while loop, that's an infinite loop that just keeps running until we kick out, is actually just going to keep running and lock the browser until that loop finishes. So JavaScript is single-threaded, so we can't have some sort of loop running in that manner. We actually need to have an event-based loop that utilizes some of the things that are in the browser to actually do that loop for us. So to better illustrate what I mean, is I'm actually going to set up a couple more things here. I'm going to set up a public method, and we're going to call this start. And it's going to be return type void. And I want to mention in TypeScript, when you're declaring the type of a variable or a method, it always has this colon followed by the type itself. So what this is basically saying is this method doesn't return anything. And so we're saying when we call start, we're not expecting anything to be returned. Obviously, on constructors, you can't specify a return type, so we don't do that there. But it's always a good practice to always declare not only your scope but your return types on all your functions. And the next function I'm going to create is going to be a public. Actually, I'm going to create a private loop. And that's not going to take in anything as far as parameters either, and it's going to be a void return type. So this loop method is what is actually going to be called every time we loop. So every time we go through a game loop, this method is going to be called. And so to kick this off, what we're first going to do is we're going to first eventually perform some startup code in our start method, and at the very bottom we're going to call this.loop. So we're saying we want to call loop against this instance of the engine. And so that's going to call loop once. And the way that this is going to work is we are actually going to use something called request animation frame. So request animation frame for most browsers runs about 60 times a second. It winds up working really well for games. It was designed primarily for animations or anything done in the HTML5 canvas API to allow for more dynamic applications. And so this is going to work perfectly for us to set up our loop. So what we want to do is we want to request an animation frame at the end of every loop that we do. So by the time we do our basic game looping logic up in this area, and by the time we get to the bottom frame, we want to say request animation frame. So it's basically saying the next frame, we want to go ahead and request that from the browser. And there's a little bit more to it than that, but I'm just going to kind of gloss over that for now, and we'll come back to it later in some of the more advanced topics. Request animation frame, it's looking for a callback. And the callback is basically going to say, all right, when I get my next animation frame, what method do I call? And so we want to actually set it to this.loop, but instead of calling this.loop like you would expect, like this, we actually want to say .bind this. And what this does is it's basically saying we want to call engine.loop for this instance of engine.loop. We don't want to call it for another instance if we created a second instance of it. We want to call it for this instance. And the whole this and bind, that is a whole topic all of its own, so I don't really want to go into that too much. We're not going to have to do it very often, so just take this sort of at face value for now. That what this is doing is basically saying we want to call loop against this particular instance of the engine. And that is all that's going to be required to actually set up our loop. So in order to prove this, what I'm actually going to do is I'm going to set the document.title, and I'm actually going to, before I do that, let's go ahead and create just a small private variable within the engine. And I'm going to call this underscore count. And I like to use underscores for private variables. It's just a convention that I picked up over the years, and it makes it really obvious when you're reading through the code later on that it's a private variable because it starts with an underscore. So that's going to be of type number, and I'm going to default it to 0. Now, defaulting it to 0 here is pretty much the same thing as if I were to say, let's get rid of this hello. If I were to say this.count equals 0, it's pretty much the same thing. Whenever an instance of this is created, it's created with the default here. So You could do it either way. This is a little bit more clear in some instances, but in other instances, maybe you want to do this. It doesn't really matter. Whichever way you prefer is fine. I'm actually going to just keep it up here. So what we want to actually do before we say document title anything is we want to say this.count plus plus. And so what we're actually doing there is we're incrementing that count. So it starts at 0, so every time loop runs, it is going to increment its value by 1. So the first time it runs, it'll be 1, the second time it runs, it'll be 2, and so forth. And to prove that this is sort of working, we want to do document.title equals this.count.toString. And what that's going to do is that's going to replace the document title with the value of this.count cast to a string. So I'm going to go ahead and build this and run it. And it didn't work. Did we get an error? Ah, I know what it is. Okay, so let me close this. Problem is we never called start. So this start is what ultimately kicks everything else off. So I actually need to say e, because that's my instance, dot start. And let's build that. Run. And now you'll note here that this is updating pretty fast. The browser is actually limiting us as to how fast we can actually update this text. But this is updating roughly 60 times a second. So this right here is proof that our game loop works. And with that, I'm going to go ahead and stop this video here because it's already gone on pretty long. And in the next video, we're actually going to jump into setting up our page and our canvas element and initializing WebGL in order to actually set up a viewport that we can render to on the screen. And we're going to set up a couple of other things within the engine as well. So with that, thank you guys so much for watching. I hope you enjoyed. I hope you learned. Let me know what you guys think of this video and if this is a series that you think will be useful to you. And I will see you guys next time.